A lot of students having a lot of problems understanding subnetting, so I'm going to make subnetting like chicken feed for everybody who's doing network management, one or who doing the Cisco CCNA exam. So let's start on a basic IP address of 201.67.135.0. First, let us determine what class this IP address in. So we're going to just go next and determine the exact classes this particular IP address falls under. And as we would see, we would notice that this IP address falls under class C, since the first octal falls between 192 and 223. This IP is a class C address, and as you could look at class B address, which falls between 128 to 191, and then class A address from 0 to 126. So let's move on a little bit to get down into the heart of subnetting and paying attention to that particular IP number that I use as a default. So let's begin. 201.67.135.0. Now let's determine the subnet mask for it. So a class A subnet mask would be 255.0.0.0. Class B will be 255.255.0.0. Since our IP address is a class C, its subnet mask must be 255.255.255.0. The purpose of a subnet mask is to tell us which portion of the IP address is the network number and which portion is for the host address. However, to see how this works, let's convert both the subnet mask and the IP address to binary numbers, because at least you will still need to understand the whole concept of binary conversion, which you're supposed to learn in an earlier course. So let's begin. We begin by looking at the numbers that are represented up there in terms of the IP numbers, and you're also supposed to know how to do conversion of binary numbers back to decimal and decimal back to binary. Like for example here, this starts off at 0000000 here, so this is 0, which means this is all is off. How did we arrive at this number here? We put on 1, then we put on this one here, and so on. But how do we add up all these numbers to actually get it? So the first one here would be a 1, and then this would be a 2. This is 2 to the power of 1. There's 2 to the power of 2, which will give us 4. This is 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. So this number up here would be actually 128. So we have 1, 2, 4, 8, 16, 32, 64, and 128. And all you need to do is just add the numbers that are on for you to actually get this number. Same thing here. Add the 1 and the 2 and the 64, and you're going to get 67. When all is on, then you have a subnet of, well, a binary number. These are the binary numbers here, but you have a decimal number representing 255. Now, if you're having problems understanding this, I suggest that you go and take a course in learning about binary numbers and binary conversions and so on. So nonetheless, the digits represented by ones in the subnet mask designate the corresponding digits in the IP address equal the network number or the specific address. So the digits represented by zeros in the subnet mask designate which corresponding digits in the IP address are allocated for the host address. So this would be the network address here, and this would be the number of hosts. This is the part here where you're going to do most of your subnetting, because this portion here is really the network address, and this is the portion that you need to allocate for your number of hosts and so on. Let's move on. So subnetting a class C network is very simple. Like a class C address, there are 8 bits available for host assignments or a combination of subnetworks and host assignments. Let's demonstrate how we can borrow some of the host bits and convert them to a subnetwork bits. We must borrow a minimum of 2 bits. 2 bits gives us 4 subnetworks: 00, 01, 10, and 11. However, only 2 of which are usable. The first and the last subnets are unusable because they contain the major network or network's address 00 and broadcast address 11 in this case. Let's say you need 13 unusable subnets, just for say. You really need 15 subnetworks because the first and the last subnetworks in each subnet array are unusable. Let counts bit from left to right using the powers of 2. The same thing that I showed before. 2 to the power of 0 is 1, 2 to the power of 1 is 2, to the power of 2 is 4, and so on until we equal and just exceed the number of subnetworks. And just take into consideration we're looking at 15 in which we need. So let's borrow bits and give 2 subnets. And remember, you must borrow at least 2 bits. So 2 bits will give us 4 subnets. 3 bits would give us a total of 8 subnets. And the list of the 8 subnets are shown here. We are short of 15 needed. So 4 bits would give us 16 subnets. So borrowing another bit for a total of 4 bits gives us 16 subnets, which is 1 or more than we need. Let's look at each one. Since we borrow 4 host bits and convert them to subnetworks bits, we must adjust our subnet mask for the new subnets. Let's bring back our original subnet mask. Since we borrow 4 host bits to create our additional subnet, we must convert the corresponding bits in our original subnet mask from 0s to 1. Click here to convert. After converting the binary digits to decimal, we can see that our new subnet mask is 240. How did we get this? Again, if you go 2 to the power of 0 is equal to 1, 2 to the power of 1 is equal to 2, 2 to the power of 4 is equal to 8, 2 to the power of 5 is equal to 16. So you have 1, we got 2, 4, we have 8, 16, sorry here I'm showing here, 32, 64, and 128. How did we get 240? So all we need to do was to add up these 4 bits to get 240. I'm going to move to my calculator now. I'm going to just drag it onto the screen, and I'm going to calculate them. So I have 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8, 16. So I have 16 here. I'm going to add this now to 16 plus this would be 32. So I have about 32. And I'm going to add this now to 64, and then I'm going to add this last bit now, which is 128. And this is how I got my number here, 240, as a subnet mask to have at least the 15 subnets that I'm looking for to work on. So let's minimize my calculator here for now and move on with my video presentation. So in order to know how many bits to borrow, you need to determine one or two things. How many node or host IP you need for each subnet, and how many subnets you need. Let's say we need to get about 600 subnets from a class B network. Now let's work out this one, which would be presented in exam for both courses and also at OS platforms. So for 0 subnet we get 0 count. For 600 subnets is still needed. Let's count off the bits as we move forward. So 2 subnets you get 1. Counting off the bits, 2 will give us 4 subnets. 3 will give us 8 subnets. And just remember we are looking at 616. And remember it's class B addressing, by the way. 64, 128, 256, which we passed already, 512, 1024, which essentially exceeds our requirements for 600 subnets, and this is the closest bit count to meet our needs. What do we do now? First, now that we borrow 10 subnetworks bits, we must remember to adjust our class B subnet mask from 255.255.0.0, which is 16 bits here in this case, to 255.255.255.192, 26 bits. How did we arrive at 192? When we have the 255 showing up here, then we have, in this case here, we are supposed to add these two numbers. This one would be 64 and this one would be 128. I'm going to bring my calculator back here again, and I'm going to clear this. I'm going to add 128 plus 64, and I get 192 here. So you may also base your subnet decisions on the number of hosts you need in your subnetworks. Let's assume you need 250 hosts per subnet. Remember, you really need 252 hosts because the first and the last address, as I said before, is used up. Let's count off the bits until it's equal or just exceeds the 252 hosts we need. As we move up, 8 hosts, bit count 4, 16 hosts. We're still looking at 252, 64, 128, and 256. Now that we determine how many host bits that we need, remembering 8 bits will give us 256 subnets and be used for subnetting. (256) 8 counts. Now you're ready to do some subnetting, courtesy Cisco Networking Academy.